Today in class we learned about the difference between relations and functions. A relation is basically any old set of ordered pairs. So any set of ordered pairs, like a scatter plot, a graphed line, a list of ordered pairs, a bunch of values in a table. Anything is a relation. So any pieces of data that you can put in a graph, table, ordered pairs, equations is a relation. A function is a special kind of relation in that in a function we don't repeat any x values. We don't repeat inputs. So let's talk a little bit about what that looks like. First of all, the first thing that we kind of look at, I talked about it today when I talked about the Coke machine, how like if I go to the Coke machine and I hit the Dr. Pepper button, a Dr. Pepper should come out. You know, like I shouldn't get a Sprite sometimes, a Dr. Pepper sometimes, a can of green beans sometimes, an angry dog jump out and bite me in the face. It should be predictable and consistent. So if I hit the button and something inconsistent happens, that means I don't have a function. It means my machine is not functional. When I look at a mapping diagram, that's kind of what I'm seeing. I'm saying that if I hit the -4 button, I'm going to get 9. If I hit the -1 button, I'll get -6. If I hit the 1 button, I'll also get -6. But that's okay, because it's like in a Coke machine where I have 2 Dr. Pepper buttons. Hey, there's nothing wrong with that. So it's okay to have 2 arrows pointing at one thing. That just says that -1 goes to 6 and 1 also goes to -6. I'm sorry, I meant -6. All right, and the 3 goes to 11. But if I look here at this 3, this is like saying I hit the Dr. Pepper button and I could get Sprite or Dr. Pepper or green beans and angry dog. All right, there should not be any question about what's going to happen when I hit that button. It should be completely predictable. So this is a function and this one is just a relation. Okay, now let's take a look. We've also got tables. When I look at a table, okay, I want to make sure that I don't have any x's that are duplicated, because if I have duplicated x's, that means that x has more than one thing that could happen. So if I look here, I only look at the x value, because remember, it's okay for me to have 2 Dr. Pepper outputs. It's okay for the 2 different buttons to give me a Dr. Pepper. It's not okay for my Dr. Pepper button to give me 2 different things. All right. So if I look at this, I've got -3, -1, 3, 1. Even though -3 and 3 are both 3, they're different numbers because negatives are different. Okay, so this is a function. Even though 6 is repeated here, again, I don't care about that. When I look over here, 8, 3, 5, 5. 5 can give me 1 or 8. That's not going to work for me. This is just a relation, so it's not a function. Okay, again, a function is a special relation. Now, when I look at graphs, I'm looking to see if I have x values stacked up on top of each other. Now, the way we do this is with the vertical line test. So literally, you take your pencil and you run it along. Now, I'm not talking about the grid in the back or the x and y axis. I'm specifically talking about the points that are plotted, okay? And if it was a line, I'd look at the line too. In this case, when I look at this, I have only 1 point, only 1 point, only 1, only 1, only 1, only 1. This right here is a function because my pencil didn't touch 2 points ever at the same time. Over here, though, oh my gosh, I fail as a function right here. And then, oh my goodness, I fail again right there, because this is saying 1 gives me either 1 or 2. That's not a function. If this is saying an x value of -2 gives me either a 6 or a 9. Also not a function. So this is just a relation. Now, when I look at ordered pairs, same thing. Just like with tables, I don't care about y, I care about x. So I'm going to look at my x values. -6, 3, 2, 4. That's a function because every one of them is different. When I look over here, I have -3, 2, 2, 6. So this means when I push the 2, I could get a 1 or a 4. And this one is just a relation. Okay? Now, when I talk about situations, situations have to make sense and they have to be a predictable statement, a statement that kind of allows prediction. So the amount of time I study determines my grade. If I study like not at all, I'm probably not going to get a good grade. Unless I'm like some kind of crazy prodigy, and like that's not, we don't use the exception, okay? In general, the more I study, the better my grade is. This is a functional statement. My hair color determines the weather. It does not. I have had brown hair my whole life, and there has been a multitude of weather that I've been exposed to. This is not, I don't even know if this is a relation. It's not a function. I know that. Okay? I've had nothing but brown hair my whole life, and I've had, all kinds of weather. So this is kind of a general review of functions. In addition to our general review of functions, we also talked about function notation as a new concept. Now, this was kind of a mess, so we're going to kind of go through this. I'm going to go through these notes. I didn't get them finished, so I'm going to go through them with you. If you're able to watch it, great. If you're not, I'm going to give you all a little bit of time to do this tomorrow. But still, here it is. A relation is a set of ordered pairs. Okay. Yeah, I'm looking at the key over there. Where I want to make sure I do it right. Where x is the input value and y is the output value. Okay, and actually for function notation, well, we'll talk about that in a minute. Okay, a function can be thought of as a machine that assigns one output to every input. Okay, so what I'm saying here is, again, just the same thing we talked about before. I have one output for every input. That means every button I could push on that Cook machine is only going to have one possibility of happening. Okay, so now if I go down here and I actually look at this, this is function notation. Okay, so relation, what they're saying up here is a relation is any old set of ordered pairs. A function is a special relation, just like a Snickers is a special kind of candy bar, and chocolate chip cookie dough is a special kind of ice cream, okay? A function is a special kind of relation. This, what we're looking at right here, though, is called function notation, and it's a new thing that we're going to say. So f of x means the output of the function f when the input is x. And we usually call it y. I'm not really going to get into why because I don't want to blow your minds, but for now, let's worry about learning how to use these problems, okay? So f of x, well, f is the name of the function, okay? X is it tells us what number to plug into the function, okay? 3x plus 4 is the function. I know I've said function like 12 times here, okay, so maybe that's confusing. So remember we talked about my sad little function machine? I do remember it kind of looked like this. It had like a spout, a sad little spout right there. And then over here it did stuff, and then out came my results, okay? And remember I talked about the meat grinder. So I talked you put chicken in here, and then the meat grinder does its thing, and it grinds it up, and boom, out jumps ground chicken. Or I put beef in here, and the meat grinder grinds it up, and boom, out pops ground beef. It's the same thing. They're saying this is the ground beef. This is the beef that I'm going to stick into the meat grinder, and it's going to shoot out ground meat, okay? So I stick in beef into the meat grinder, it spits out ground beef, okay? That's what this is. I mean, I know meat grinders is kind of super gross, but that's the best example I can come up with, okay? So when we look at actual problems, well, first of all, what you need to understand, and I said this in class today, and I mean it, this thing right here, this is a function machine. In fact, if you notice, the only types of graphs we can graph are y equals. If we want to graph, for example, a circle is not a function because, when I draw a circle, right? I mean, it just does nothing but fail the vertical line test all day long, okay? If I want to put a circle into this calculator, I got to use two functions to make that happen. I got to use one to draw the top and one to draw the bottom because this calculator does nothing but draw functions. Well, that can help us when we're doing our function notation, okay? So when it says find f of 2, it's saying use that x value in that meat grinder and tell me what kind of ground meat you get out. Okay, so I'm going to say f of 2 equals 3 times 2 plus 4. Okay, well, 3 times 2 is 6. 6 plus 4 is 10. So f of 2 is 10. Okay? Likewise, this says f of x equals 7. I want you to think of f of x as a variable. F of x, anywhere I see f of x equals something, I can substitute into my original equation. So if f of x equals 7, and my equation is f of x equals 3x plus 4, then 7 equals 3x plus 4, and I can solve this thing. I subtract 4 from both sides. I get 3 equals 3x, divide by 3, x equals 1. Okay? So what this is saying is when x is 2, y is 10, or f of x is 10. When x is 1, well, when f of x is 7, x is 1. Now, we can also do this with our calculator. Okay? So if I turn on my calculator, and I'm going to clear it up because I don't even know what's been going on here. Okay, when I go into y equals, I can put this function, because again, this calculator is a function machine. 3x plus 4, and then I go second graph to get to the table. It says, what is f of 2? Well, 2 is an input variable, which is x. When x is 2, y is 10. Hey, look at that. That's the same thing I got. If I want to prove that I did this in the calculator, actually, I don't even need y2, do I? I put 2, 10. There you go. That's how I got it out of the calculator. Let's take a look at f of x. When f of x is 7. Okay, well, let's get over here. Oh, hey, look at that. When f of x is 7, y is, well, when y, which is f of x, is 7, x is 1. So that's literally all we're doing when we solve these kind of problems.